Go on. Okay, Bismillah. Okay, folks, welcome back. We're looking at Unit 16. It says it's circle theorems, but it's actually circle theorems that kind of overlaps with straight line equations and the equation of perpendicular lines and the gradient of perpendicular lines. So this is from the higher core book, from the edXL book, page 514, Unit 16. It's on page 514. Okay, right. So the example, there's an example up here. It says find the equation of the tangent to the circle x squared plus y squared equals 25 at the point 3 minus 4. So that's the question that we're going to be repeating again and again. So let's get ourselves a good little kind of grip of what this question is all about. Now in this example, they've actually given us a sketch of the diagram, and I would advise that we all do a sketch for the questions that we're about to do and put the point on there as you see there. So all the circles start off with the center 0, 0, and this particular one goes off to a radius of 5 because that's what the equation's all about. You have x squared add y squared is equal to r squared. So the last part of the answer here is r squared equals 25. So if I want to work out the value of r, I'm going to take the squared over. So r equals the root of 25. So r is equal to 5. So if you look over here, that's why if you draw the radius line from the center of the circle, it will go up to a maximum of 5 in each direction. That's basically the radius of the circle. And then the question is talking about this line here, this segment O to A. And then we're looking at, after that, we are thinking about the tangent T, which is the blue line over here. Okay, now from the highlighted part of the question, okay, let's have Ismail, can you please join me on this question? Okay, so in this question here, at the moment, we don't need to be too much concerned about this part of the equation for the moment. Okay, because x squared plus y squared equals 25 is going to be, it becomes more relevant in one of the questions that we do later on, where it's like examination style question, where you have to work out the radius, and we need that radius value, which I've just worked out for free earlier over here in our video at the beginning. So Ismail, how do we start this question? So it wants us to work out the equation of the tangent. So it wants us to work out the equation of the blue line. How do we go about working out equations of the blue line when we have a circle sketched in front of us and a point on the blue line and the purple line being the radius of length 5? What do we do in this particular question? How do we start off?
Find out the gradient of the line.
We find out the gradient of which line?
Blue one.
We find out first of all the gradient of the
Purple.
Of the purple line, because the gradient of the purple line and the gradient of the blue line are related. So once you find out one, you can find out the other. So now, if I want to work out the gradient of the purple line, okay, what can we work out? So to work out the gradient, we need a triangle. Okay, we need a triangle to work out the gradient. So the gradient is what? Define the gradient is equal to
y2 minus y1 over x2 minus x1.
Yeah, so what? So gradient in its more simplest form is the height of the triangle divided by the base of the triangle. Now the height of the triangle is given quite nicely by the coordinates. So there's the height. So what's the height?
-4.
And what's the base?
3.
3. So we can actually literally, so this is going to be my x value, that's going to be my y value. So put -4 on the top and 3 on the bottom. Lovely. So I'm looking at the gradient of the purple line. Yes, Alia? Is it okay? Looking at the gradient of the purple line, the radius, and that's -4 over 3. Now, how do I get from there to the gradient of the tangent? So the gradient of the...
You use the m1 times m2 equals -1.
Okay. Or we could just
you
make
do
a
the
little
negative reciprocal.
That's
it
a
becomes 3 over 4.
Lovely. So we can do here the negative reciprocal, okay, which we're going to get the -4, so we're going to throw it upside down first. Oops. We're going to move it upside down, turn it upside down. So the -4 over 3 gets flipped into 3 over minus 4, and then we have to multiply it by minus 1, which gives us
-3 or -4, which is 3.
So if we get minus 4/3, we flip it upside down, we get 3 over minus 4, and then we multiply by -1 by minus, that makes it all into plus. Are we happy with that gradient of the tangent being 3/4?
Yeah.
Are we happy with that? Lovely. So first of all, we worked out the gradient of the purple line, the radius, which was minus 4/3. Then we did the negative reciprocal of that, got the gradient of the blue line, which is the tangent. Okay, lovely. So let me just grab a hold of some of this. And now, okay, so there we've done that question over there. Now we need to work out the equation of the tangent now. What formula do we use for the equation of the tangent?
Y minus y1 equals m bracket x minus x1.
Okay, now for this particular equation, how many data items do we need to know before we start the question?
3.
3. So what is the data items? It's going to be what values?
-4, well, it becomes +4.
Yeah.
And then 3/4, and then 3.
So your data values are
Nice.
right here. So let's number them. So you need the x value, the y value, and you need the gradient of the tangent. You need those 3 values. So I'm just going to cut them out from here. I'm going to copy that. I'm going to write it up here. Okay, let's put it up here. Let's make it a little bit smaller. Bring it down a bit. Okay, let's grab this one here as well. Grab this. Copy. Paste. Make it a bit smaller. Put it over here. So I like all my values to be like in a nice local space next to the equation that we're going to be using. So far, we had to work out the gradient of the original line. We had to inverse. We had to do the negative reciprocal of that gradient to work out the gradient of the tangent. Then we use the coordinates that the tangent will go through, which is the point of contact with the circle. And then we're going to put all those 3 values into our equation. So off we go. So let's start the substitution process.
Y minus -4 equals m.
So we do y take away -4. That's right, because y is -4 right there. Lovely. Equals
3/4 bracket
3/4 bracket
x minus 3.
X minus the x value, which is over here, 3. Lovely. Now, one thing I realized, I think some of the students were doing in the homework, you were putting the x value into the y and the y value into x, you're mixing them up. You have to make sure you put in the y1 value as the y1, the x1 value as the x1, and then we're on happy days, hopefully. Okay, now what? Let's finish the question off. Let's go.
So the y minus -4 becomes y plus 4.
Okay, so the 2 minuses convert, they become a +4. Oops. All right, let me get rid of that. They get transformed. Okay, next.
3/4 x minus -9/4.
Okay, lovely.
And then you subtract the -4.
Okay, so we now have y equals, everybody should be copying all of this down. So we've got -9/4, and the +4 becomes
16/4.
-16/4. That's a lovely way of thinking about it. The +4 becomes -4. -4, you're converting it into top heavy fraction. So 4 has got 16 quarters in it. So okay, let's try to tidy this up now. So y is equal to 3/4 x minus 9/4 minus 16/4 gives you how many?
-25/4.
-25/4. Now, the way that the exam paper, or sorry, the answers are given in the back of this particular book, they don't want you leaving the answer like this.
You just do 4y equals 3x minus 25.
So what are you doing then? What do you do?
Multiply by 4.
Multiply everything by 4, every item. So we get now 4y. When you multiply this item by 4, the 4 will get cancelled, and same for that as well. So we just be left with the top part, which is 3x, left with the top part, which is -25. So this is answer that's the preferred answer for that question. So in this particular question, I reused, or I used the diagram that they gave us. Now, when we're going to be doing our own questions, which are down here, which have been kind of reset out for us, we need to draw our own diagram just to give ourselves that kind of visual confidence that we are happy with all the information that we have in front of us. So question number 9, Layla, please. Thank you for that, Ismail. Jazakallah for that.
Welcome.
Layla, can you join me on the next question, please? So I'm
Yeah.
going to do one more without a diagram, and you're going to help me do the diagram. We can do this one together, and then I'm going to let you guys loose on the couple of questions which are underneath, just to give you that level of confidence that we all need to do this question if you were given this exam in the examination. So, Layla, read the question to me, please.
Find the equation of the tangent to the circle x squared add y squared equals 169 at the point B, 5 minus 12.
Okay, lovely. 5 minus 12. So let's have a little sketch over here. Okay. Okay, now, because normally you have x squared add y squared equals r squared, and r squared equals 169. What would be the value of r, Layla? Just as a side question.
The root of 169.
Which will give you what?
1 moment. 13.
Yeah, just as like a little bit of a side information, that's the, we don't need to worry too much about that for the moment. So basically, we're going to have to draw a circle, and I'm going to try to draw my circle. Let's do it in a black, and I'm going to try to draw a circle. Okay, that's a little bit. So basically, these values up here, that would be plus 13, that would be plus 13, that would be minus 13. That's not something that you need to kind of know too much, but I'm just kind of giving you a little bit of extra detail on the question. So it joins the point B at 5 minus 12. So you have to kind of now think, where would 5, that's 13, 5 minus 12 would be around about, say here.
Yeah.
So, okay, I'm going to try to do the same colors that we've done in the previous question. So we kind of keep it solid. You can pass me a ruler. Go on here. Go on. I'm going to use a ruler and try to give myself a nice tangent here in blue. Okay, so the tangent, I'm just going to call it T, and this is the point of contact. This point has a value of B. Actually, let's not write it in blue, let's write it in black for the moment. So this is point B, which is 5 and minus 12. If you want to have that kind of visualization effect, that would be a nice way just to quickly sketch it. That's not imperative, but I find that it does normally help. So if you look at the question, how far does the point come down, Layla?
5. Oh, minus 12.
Minus 12, that's your y. So that's going to be, that point would be minus 12. It'll be how far it comes down. How far will it be across for the base?
5.
5. There you go. So really, I mean, in a sense, if you didn't do the diagram, it doesn't matter. You grab your coordinates, you put the y coordinate over the x coordinate, and your job is done. So let's work out over here on the side here, first of all. Let's work it out. So the gradient of OB. So OB is the line segment from the origin to the point B, which is basically the radius, which is the purple line. Okay, let's just do that in purple to keep the color scheme running. So my colors in the calculation match the colors of the diagram. So what's the gradient normally in the simplest form as y over
X.
x. So, and what was the y value again?
12. Minus 12.
Minus 12. So put minus 12 over
5.
the 5 from the coordinates. So we're basically using this values here straight into the gradient. Now, what will be the gradient of the tangent? Now, let me change to a blue. So keep the color theme running. So I want to work out the gradient of the tangent t. What do we do with minus 12 over 5?
Divide it. Oh no, you find the negative reciprocal.
So minus 12 over 5, you've got to flip it upside down first of all, and then multiply it by?
Minus 1.
Minus 1. So if we flip it upside down, we get 5 over minus 12. If you multiply that by minus 1, that gives us what finally?
5 over 12.
That gives you 5 over 12, absolutely. So that's the grade, that's the number that we want now in our next calculation. So let's change color once more. Let's go for a different color altogether. Now what's the, so now that we know the gradient of the tangent, which is here, and we know the point where the tangent touches or point that the tangent runs through, what do we do next?
You find the equation with the formula.
Y minus?
Y1 equals m brackets x minus x1.
Okay. Okay, so think about it, the steps that we've done so far. We've done, oops, we've done 1, 2, 3. So now the 3 values that we need to put the y1 and x1 values in there. So my y1 value is here, my x1 value is here, and my gradient is here.
Mhm.
So we say y, take away y1. What's y1?
Minus 12.
So y minus 12 equals the gradient. What is the gradient that we need?
5 over 12.
5 over 12 times by x minus
5.
x minus 5. You've got to put the right numbers in the right part of the formula. Now, I have a feeling that we're going to be kind of running out of space. I don't know, but this is this, can we cut this out on? Okay, we are literally, oh, maybe I can just squish it up a bit. Give me a second. Oops. Oops, I don't want to do that. Let's undo that. Okay, no, I think I'm deleting stuff. X minus 5. Okay. And then I wanted to do this. Okay, hopefully I'll have a bit more space now. I'll try to write a bit more small as well. So you have, what do you have now? What's y minus 12?
Plus 12.
So we have y, oops, I think maybe make the pen a bit thin as well. So you have y plus 12 equals?
5. 12 of,
okay, no,
5 over 12, sorry, x.
Sorry about that. I'm not happy with how that's kind of looking. That's just looking too, okay, let's put the 5 over 12 over there. So I don't want to crash it. So we have y plus 12 equals 5 over 12x minus?
25 over 12?
Absolutely. I think this is where you got a little bit confused on some of the calculations that you were doing earlier.
Yeah.
And number one, you were squashing it too much and then you were confusing yourself. It wasn't too clear. What do we do with the plus 12?
Bring it over to the other side.
Now,
Minus 12.
now remember, if you bring plus 12, it becomes minus 12. If you keep the theme running as 12s, that'll be minus?
144 over 12.
Yeah, because in each whole number, we have 12 12ths. So we have minus 12 wholes. So in the minus 12 whole, you'll have 12 12ths times by 12, which gives you the 144. So that's lovely.
Yeah.
So now we have here y is equal to 5 12ths x minus, now what's 25 at the 144?
169.
Over 12. Now, as I said to you before, even though you can leave the answer like this, the preferred format for the moment is you get rid of the fractional part from the bottom. So we can get rid of the fractional part from the bottom by doing what to everything?
Multiply by 12.
Multiply everything by 12. When you multiply everything by 12, this item by 12, this item by 12, and this item by 12, the 12s disappear from underneath. And so we'll end up with the answer like this. So the first y becomes 12y, because I'll multiply by 12. The 5 over 12x times by 12 will give us simply 5x. The minus 169 over 12 will give us what?
169.
Done. Finished. So drawing the diagram is not absolutely essential as long as you understand that your coordinates for your radius will be your y value over the x value. If you can understand that, then if you were to miss the circle drawing, I wouldn't mind too much, as long as you have the key elements to this question. The key elements being working at the gradient of the original radius by just literally using the x and y and x coordinates, then flipping the gradient upside down and getting the negative reciprocal gradient, then using the correct equation, putting the numbers in, rearranging it carefully, keeping it all top heavy fraction or mix or prop fraction, and getting rid of the fractional part completely, and ending up with a nice, lovely, finished, beautiful answer that looks like this, which is the examination paper ready. So that's what's required. So the diagram is like a bit of an extra. I don't want anybody spending hours and extra 20 minutes doing the diagram, but the most important part is the purple bit, the blue bit, and the orangey yellow formula, and then all the black calculations underneath that, and the manipulation. And you need to keep it nice and clean and clear. So I've purposely made things smaller. I've moved things out of the way. Don't crash calculations into other calculations. The last thing you want to do in the exam is confuse yourself. Forget about confuse the examiner. Is confusing yourself and then making a dog's dinner of the work, and then you get lost, or you get anxiety, frustration, think, oh, what's happened? I've lost the question. But there's no need for that. Nice and carefully, think about what you're doing, keep it the fractional team running, get rid of the denominator, job's done. Okay, I'm going to pause the video here for the moment, because we don't need to record, hang on a second. We don't need to record big pauses while you guys do some questions.